New plan. Steal the towels and resell them to get enough money. Dude, okay. New plan after that. Now we take all the money that we got from selling them, and then we put it all on black, and then think about it this way. We got double the money. Easy. Guaranteed. Linen layout. Day 19. Today, the historians take you up to the hot springs on Gear Island. Very suspiciously, absolutely nothing goes wrong as they begin their careful search of the vast field of helixes. Could this finally be your chance to visit the onsen next door? I actually don't know what that is. Oh, like a Japanese like hot spring thing? Oh, that's cool. Only one way to find out. After a brief conversation with the reception staff at the onsen front desk, you discover that you don't have the right kind of money the money to pay the admission fee. However, before you can leave, the staff gets your attention. Apparently, they've heard about how you helped at the hot springs, and they're willing to make a deal. If you can simply help them arrange their towels, they'll let you in for free. Why do I have a feeling this is going to be the most convoluted way to arrange towels? Every towel at the onsen is marked with a pattern of colored stripes. There are only a few patterns, but for any particular pattern, the staff can get you as many towels with the pattern as you need. Cool. Each stripe can be white, blue, black, red, or green. Okay, and they're each marked by a letter. So a towel with the pattern GGR would have green stripe, red stripe, in that order. You can't reverse a pattern by flipping a towel upside down, as that would cause the onsen logo to face the wrong way. Okay, cute. The official onsen branding expert, the OOBE, the out-of-body experience, nice, has produced a list of designs, each a long sequence of striped colors, that they would like to be able to display. You can use any towels you want, but all the towel stripes must exactly match the desired design. So, to display the design RGRGR, you could use 2 RG towels and then an R towel, an RGR towel, and then a GR towel. Oh, we've done stuff like this in the past, okay. Or even a single massive RGRGR towel, assuming the towel patterns were actually available. To start, collect together all of the available towel patterns and list of desired designs, your puzzle input. For example, okay, so here are the puzzle patterns that we have available, and here are the patterns we have to create with them. The onsen has unlimited towels. Okay, so they have unlimited towels of R, unlimited towels of WR. Okay, yeah, so this is what they have, and they have an unlimited amount of them, so we can assort them however we want. The first line indicates, oh no, I already read that. After the blank line, the remaining lines each describe a design that they would like to display. In this example, the first design, BRWRR, indicates that the onsen would like to be able to display a black stripe, a red stripe, a white stripe, then 2 red stripes. Okay. Are these going to be possible? It seems like there might not be like enough to make it. Not all designs will be possible. Bro, I just have to learn to read. Like, I literally just have to learn to read. Are you kidding me? In the above example, the designs are possible or impossible as follows. Okay, BRR can be made with a BR towel, WR towel. Okay, so it doesn't matter how many times we can make it or how many different ways it can be made. It just matters if we can or not. A simple boolean of yes, it's possible, or it's impossible. In this example, 6 of the 8 designs are possible with the available towel patterns. To get the onsen as soon as possible, consult the list of towel patterns and desired designs carefully. How many designs are possible? Okay, cool. This is very straightforward. All right, let's grab this puzzle input. No, wait, hold on. We're jumping the gun here. Let's go to the terminal and figure out where we are. Make dir day 19. Cool. So now we're in day 19, and oh my god, that emote's wild. Example input dot text. Yeah, no, text. There we go. Real input dot text. I am so afraid to look at the real input, but don't worry, none of us are. I'm gonna grab it. Grab the real, oh my god, the real input is gigantic. I know I say that every time, but like, bro, come on. It just looks like nonsense. All right. So, now we're here. Example input, real input, part 1. Start writing some code. I already have a couple ideas on how I'm going to do this, because we've done similar stuff like this in the past. We have to chop this thing up and then figure out how many ways we can reconstruct it. I don't think this is... Alright, so what does our example input look like? The first line is all of the things. Okay, so let's read -r line. This will just read the first line of input, which will look like this. I guess we're just using the fact that standard in has like a cursor on it, and we can just consume different parts of it. Alright, part 1, read in from example. Cool, so we get that as a line. Now that we have that as a line, we can chop off the spaces. So now we're just left with commas. No. Let's chop off the commas. So now we're just left with spaces. Yeah, I think that works, right? If we echo S, we should just have spaces between them. Hey, look at that. Now we have a list of all of the possibilities. My gut is telling me to put them into an associative array so we can just check if they're available or not. No, let's just put them in a regular array for now. Read-r available. We'll just read them into an array for now. So now we have an array of available things. What we're going to do is we're going to go to day 17 and we're going to grab var dump. Where was var dump? Cool. And this is my little bash library to dump a variable. So we're going to go ahead and source in var dump here, and then we can just say var dump available. And now if we run this with the example, available is not defined. Didn't it just get defined right there? What am I doing wrong? Oh wow, the order matters. Okay. Var dump reminded me of my PHP days. Well, there's probably a reason why it reminds you of that, because that's what I was inspired by. Was actually PHP. There's a bunch of other things that do it, of course. But I think I even list that one explicitly. So I've had this code for over 10 years, but I finally got around to putting it on GitHub. It's literally just called bash var dump. You just take this single bash file, and it's just a whole entire library in one. It's just one bash function. It looks like a lot, but it's seriously just one little bash function. But it even says it was inspired by util.inspect in Node, P or PP in Ruby, and var dump in PHP. So yeah, that's totally where I got the inspiration for that. But it's cool because it gives us this kind of output, so we can look at, okay, there's the array of all possible things. Now we have to read all of the things that we want to, all the patterns that we want to make. So in order to do that, read avail towels, read all patterns. We have to read one line and throw it out. We're just doing this to read the blank line. Now we can say read array -t patterns. So now we have, this is so confusing if you've never seen it before. Now we have an array of all of the patterns that we need to do. The way that worked is we just read all of the lines in standard in. So if you look at this file, we just read all of these line by line and shoved them into an array. That's all it did. That's what the read array built-in does. So when we run this with the example input, you can see, hey, look, here's all the pieces we have, and here's all the things we're trying to create. Very, very simple. I have a couple plans here. Now my plans here, I will tell you all my plans. My first plan when I first saw this would be to take this, let's say this first one, BRWRR, and break it into all of its possible ways that it can be created. So what I mean by that, I'll show you all in my notes what I mean. If we have this, then we can create that with a single linen of that. We can create it with a single linen of this, or two linens of that. We can create it with two linens of this. We can create it with two linens of this. Like, does this make sense how I'm doing it? I don't think this is the best way. I don't think this is how I'm going to do it. I'm probably just getting characters wrong, but I think you guys get the idea. You could break it like this, and that's fine and well and good, but I don't know if I'm going to go with this solution. I don't think this is best. The next idea I kind of am thinking about is we could take these and start smashing them together, because the order is always going to be from left to right. So we can check, like, hey, this thing starts with any sort of thing. Let's see, does it start with an R? No, we're only looking at this example down here. Does it start with an R? No. Does it start with a WR? No. Does it start with a B? Yes, it does. Throw out the first character B on this one. We're left with RWRR. Go back and do the algorithm again. So just recurse into all the possible ways that we can construct it by substringing it from the left and seeing if it's equal to it. I think that way is going to be faster, and that way is probably easier to implement, if I'm being honest. So we're going to go ahead and we're going to try it that way. So the way we're going to do this is we're going to go back and we're going to look at part one, and we're just going to try for pattern in patterns. Ugh. Do, done, echo, solving, pattern. And then what we're going to do here is we're just going to exit. I'm only going to start with the first pattern so we can just do one at a time and kind of, you know, make the output easier to see. We don't need to var dump these anymore. Try to solve the patterns. Solving BRWRR. So the way we're going to do that is we're going to loop everything we have available, and we're going to see if we can do it. So, for avail, oh man. For avail in available, I hate this naming. So for everything that we have available, let's just print it out and get an idea. Oh, right, we got rid of the exit. Cool. So what we'll do is we will try this. Yeah, okay. Solve pattern. We're going to make it a function, and it's going to take the pattern itself, and we're going to put all of that into a function. That way, we can do recursion. Once you have a function, you can call yourself. Cool. For avail in available, trying avail, awesome. We need a way to break out of this function. So if -z pattern, if there's nothing to solve, then return 0. We were successfully able to solve it. Otherwise, we need to loop over all the available ways we can do it. So these are the available ways we could solve this pattern. And then we need to check if it's viable. So if let me think about how to do this. If the entire pattern string is equal to what we have available with a star at the end of it, I think that's valid. Then the echo pattern matched avail substring. We're basically doing a substring check. We're checking to see if avail is the beginning of pattern. We're just gonna run this. I need to just get some. Okay, cool. So we were trying BRWRR or whatever, and the only two that could possibly start this pattern would be B and BR. Those are our only two options that work. That's what we were checking for. So if it matched, then what we need to do is we need to do new pattern equals pattern, the original pattern that we have, and we need to chop off the available string at the beginning. So what this will do, this is bash syntax for basically saying, there's two ways we could have done this. We could have also substringed it by length, but we're basically saying, hey, the original pattern string we have, chop off at the beginning what we had available, so we're just removing it from the left side, and we're going to try again. And the way we try again, recursion. And we'll do this until there is none left. That's what we're going to do. And if we make it down here, then we return 1 because we were not able to solve it. No. Let me think about this. We have to signal through the recursion chain that we were able to do this. Yo, what's up, Travis? How you doing, man? Yeah, you are on the. That's right. You're on the screen. We got the unified chat now. We are basically here. We just need to find a way to signal through the recursion, and this can be done. Solve pattern return 0 once it finds a match. Solve pattern and return 0. Let's stick to making this very obvious. If solve pattern, then return 0. If pattern starts with avail, call ourselves with the new smaller pattern with avail removed. If this returns 0, then we know it was a success. So just stop here. Okay, cool. I think that's it. Like, I'm gonna be honest, like, I don't know why we're getting so lucky here. Yeah, like, that's it. That's it. Echo. Let's do pattern, colon, space, and then if this is true, then echo solvable, else echo unsolvable. And what does the answer want for us? They want to know how many of them are solvable. So solvable equals 0, solvable plus plus, go down here, echo solvable can be solved. Okay, I think that's it. Like, I literally think that's it. Let me just remove this. I literally think we have the logic right. Okay, it says that 1 is solvable, and then it exited the entire... Oh, right, yeah, I gotta remove this exit. 6 can be solved. That's... yeah. That's it. That's the answer, 6. Yeah, we got it. Sorry, this seems too easy. This seems way too easy. What is happening here? So we had 2 that were unsolvable, and yeah, this matches what the example said were unsolvable. I don't know what's going on, but these puzzles are working out really well for my brain. They're just clicking really well. So I guess we just go ahead and try this on the real input, right? It's a lot of input. 233 can be solved. Okay, 233. Am I crazy? Like, we're on day 19 and that felt like super easy. Like, it was a fun puzzle, don't get me wrong. Maybe, I don't know why, the solution just seemed kind of obvious. It jumped out to me really quickly. Wow. Okay. Yeah, we're crushing it tonight. Which is good, because we've been getting destroyed by some of those puzzles. We make it through, we solve them, but, like, they've been testing my limits. This one has just been, like, these have been gimmies, and it's really nice. I will take it. Congrats, thank you. Yeah, GG, yeah. Dude, crushed it, man. Oh my god. Yeah, we still got some time. Let's try part 2. I'm a little bit scared, but we'll try part 2. Are you scared now? Hey, you read my mind. The staff don't really like some of the towel arrangements you came up with. What do you mean that I came up? Okay, well, whatever. They solved it. To avoid an endless cycle of towel rearrangement, maybe you should just give them every possible option. Okay. Okay. This can be made in 2 different ways. Adding up all the ways the towels in the example could be rearranged in the design yields 16. Am I crazy, or this doesn't seem... This seems doable again. Like, right? Right? Am I crazy? The curse is broken. You no longer suck at programming. Hey! That's how it feels. Oh my god. Get ready, world. We're here to program. You know what it is? Oh my god, I haven't played piano this stream. Maybe piano is the curse. I don't want to believe that, but maybe that's what it is. Alright, well, I played piano now, so we're screwed. CP Part 1, 2, Part 2. Vim Part 2. Okay. So, where we don't have to keep track of how many were solvable. We don't even have to signal if they were solvable, because this was just our early escape. Yeah, so what we need to do... Okay. Guys, this is so easy. I hate to say this, but this is so easy. This is so stupidly easy. We just don't escape. We just don't escape. Ready? We have a solve pattern down here, and if we got here, then we solved. So watch this. Watch this. That's it. If we made it here to this part of the function, then we just increase a global counter, and this function will just get called from all different possible things. So we don't care if solvable, unsolvable, whatever. We would just say that possible arrangements. I think that's it. Like, I truly think that's it. 16 possible arrangements. This yields 16. Am I crazy? Like, this is... Am I really good at programming? Is it going to take 8 years? Is that the problem? Is that the problem? Is it going to take 8,000 years? Okay. This might be a problem. Well, no, hold on. We can parallelize this. So, depending on how long it takes for one to run, we can do this in the background. Yeah, okay. So... Okay, I didn't anticipate this part. Rust to the rescue. Listen, yeah, Rust would... I think Rust would be able to bang this out, no problem. Threads. Yeah, it's going to be... We're going to have to do some... Well, here's the thing. We can do parallelization, but I don't... Like, I would prefer to parallelize each pattern, but it looks like a pattern might already take some time to run. Because this is crazy. Alright, so this isn't going to finish in any reasonable amount of time. Okay. Hey, that feels good. Let's start doing something like this then. We're going to echo the pattern every time we get here, so it's going to get smaller and smaller if we did it right. Wow. We're not in a loop, right? No, I don't think we are. Sure looks like a loop. Wait, chat, this is day 19. What happened to 18? Oh, we crushed 18. We absolutely 1000% crushed day 18. And I was convinced, because we did it in less than an hour, that I should try day 19. And we're crushing day 19. I already knocked out day 19 part 1. We're on day 19 part 2. We're bumping against the fact that it's going to take 8,000 years to run. How do you tell how deep in a function you are? Is it func name? I think it's this. Okay, so not super deep. At the same point now, interested in your ideas. Yeah, we're gonna see what happens here. Recursion possible? I don't know what you mean. We are recursing. We're doing recursion. This number on the left tells me how deep in the recursion stack we are. So we're like 23 calls deep. Yeah, I don't think we're looping. Let me try simple.txt. We're gonna make our own. We have R, we have RR, we have RRR. And then we need to construct this. See, that went so much faster. What is... Oh, there's just so many different available patterns. I guess looping over each one that's available is probably the problem. I know it was part 1, not part 2. I just needed to see if it would finish at any sort of reasonable time. No, I should start quoting my expansions. This is how many possible arrangements of them are possible? I guess, yeah, and then every time I add one, it grows exponentially. Yeah, it's gonna be like 6,000. Just south of 6,000, so this will be like 1,100. 10,000. Okay, yeah, it's like almost doubling. Yeah, so that's it's not ideal. So let's think about this. Okay. Yeah, looping over all that are available is definitely costly. We could probably, what we have to do, is limit our domain of available patterns. So, like if we look at the real input, our available patterns, there's so many different ones, but like if our first input doesn't even have that in it at all, we should probably filter it out. Like it'll never be possible. Yeah, let's try this. Why are there empty results in your output? That means we're done. That's when we increment possible. So if we call the function, every time we try to solve a pattern, we strip off the beginning of the one that was available. So like if the pattern's RGB and we have an R towel, we'll strip off the R at the beginning and we'll just be left with GB. If the next one's GB, we strip that off, we're left with an empty line. And when we detect an empty line, that's when we stop trying to solve that pattern because we know it's possible, and then we increment the number that were possible. That's where that came from. Played piano and you said that's easy. Maybe doing both was a bit of a stretch. Yeah. Listen, man, I did this to myself. But no, I like this. Okay. I have a couple thoughts. My first thought is to filter out things from available. So let's do this. Echo. So we have the number of available patterns. And then, yeah. Oh yeah, it says it's unsolvable. That makes no sense. We have 3 available patterns. We'll have 4 available patterns here, but we don't need the G because the G will never work. So we should check. Is bash slow? Absolutely. Absolutely it is. Okay, 4 unavailable. If the pattern... Yeah. If the pattern has avail anywhere in it, then we'll say my avail. We're just making up just a new, I don't even know. Hold on. Let me think. Foo equals this. I'm not even trying to be clever here. We're just going to use throwaway variable names. And then where we use available here. This will just become foo. It's ugly, but I don't care. We're going to see. For available patterns, using foo patterns. Cool, let's just say 4 available, we're going to use 3. Okay, so we've already filtered out some of them we're filtering. Let's see if this actually makes a difference. 447, we're using 70 patterns. 447 available patterns using 62. Okay, that's significantly less, so that's good. Yeah, Andre gave you a really good answer in the YouTube chat about Bash. So, checking 62 as opposed to 447, that's a significantly better place to be in. I have no idea if we'll get even, closer to being able to do it, but that's definitely a better place to be in. Yeah, this is one of those things that rewriting a different language, I'm sure would go super fast. But I kind of want to come up with a Bash solution. Does this finish? I just want to see if this single pattern finishes in any sort of reasonable amount of time. I could let it run and do it in Rust. I could absolutely do that, but I don't think we're at that part of the night yet. I don't think we're there. I'm not ready to give up on this at all. We're still fresh in it. I want to get an idea of what's taking so long. It's all that checking. If it starts with. We can do some more things here. We can definitely do some clever things here. So, yeah. Let's do this. Let's get the len of the pattern. This is the length of the pattern we're checking, and we'll get the avail len. This is the length of the thing that's available to us. If the len is shorter than the avail len, then there's nothing we can do. Like, it won't match. It'll never match, so we should just break out of it early. Oh, hey. Well, that's something. Throwing more threads at the pattern checking. Hey, we're gonna get there. We're gonna get there. Don't worry. Once I open Vim, it remains open. Yo, that's the way, man. I got stuck in this way longer than I should have because I didn't realize you have infinite towel dough. Oh, that's terrible. Yeah, they explicitly tell you that. Oh my god. Okay. Oh, but they're all coming across as unsolvable. So whatever logic I just put in there, I need to think about. We have the available length. If the len is shorter than the available length. Oh. If len is shorter than available len. Yeah. Yeah. Let's do this. If len is shorter than available length, meaning the length of the pattern is shorter than the pattern we're trying, then we should continue. There's no reason to try again. Okay. Something here. All right, so we're slowly making this a little bit more performant. Yeah, we're only testing 62 patterns against this string. Trying to think of ways to make this more performant. There's no... It doesn't matter what order we test the patterns in. Yeah, we have to test them all anyways. There's probably clever ways that we can take patterns out of the domain of available patterns. Because, like, if we have one, imagine letters. If we have the pattern B and we have the pattern U, then we don't ever care about pattern BU. Like, No, we do. We do. Because we have to count how many times they can be done. Yeah, wait, no. That... There could be something there, but I'd have to think about it more. It doesn't feel like Bash the bottleneck here. I disagree. I bet this could be done way faster in a different language. I could be totally wrong, but my gut is telling me that I could brute force this in a compiled language. It's so interesting that this one was so quickly unsolvable. It'll be faster, but it'll still take forever. Interesting. Yeah. It's interesting that this one's unsolvable so quickly, but this one has like so many things. I'm just wondering if there's like a B pattern, a W pattern, a B pattern. Like, who knows how deeply nested this is? I say who knows. We did the check. It was like 20 levels deep in recursion. Yeah, and every time we add a new level, it's like we're doubling how long it's going to take. So yeah, we're going to have to think of a way to make this faster. We've done a lot of good work. We're cutting down the domain of possible patterns. All right, let me do some thinking here. No reason to have spell checking on. It seems excessive. Let's think about this. Actually, you know what? The website does it better. I'm thinking about all different possibilities. So, like, right now, I'm looping what we have available and trying to construct what we want. So I'm trying to do the opposite now in my head. Maybe if I look at what we have, or what we want. So like what we want is this. If we look at this, can we break it into available patterns and then see if they match? Because we can go back to, remember how I did the notes thing. But it's so clear that this becomes like exponential. This is not, I don't think this is a good solution. Well, let me stop just prematurely throwing these solutions out. No, actually, yeah, this doesn't seem that bad. Yeah, because once you have B, then you have multiple spaces, yeah. Yeah, that's the possibility. Oh, man, yeah. If you have a 5-letter thing that you're trying to create, you can have up to 4 spaces in it. Then it becomes unruly. Yeah, this sucks. Okay. I could write a piece of logic to break all that down. Wait, hold on. I could write a piece, I could break down every single possibility. I don't know which, and then check to see if they exist in like a hash set of all my available towels. Hold on. Okay, let me think of, interesting here. Let me write a test script. I'm going to write a program that takes this pattern and breaks it into all the possible ways that we could check that pattern. Okay. New idea. Glad I wrote those notes. Turn into all possibilities. Didn't we write logic that did this? Kind of. We did it with the operations. Yeah, okay. S equals 1. Or that string. How would we break it into that? I'm just trying to think of programmatically how to do this. Yeah, I basically want to inject a space. Oh, I think I have it. Okay. It's all about injecting spaces. For I equals 1 I less than -1. I don't know. We're in brainstorming mode here. Does bash imply no set and awk? I don't know if it implies it, but for me, yes. I'm trying to avoid external tools as much as possible. I'm not against using them, but I'm just trying to see if I can do them with all just pure bash. That's my goal here. So let me think about this. So we want to inject a space at spot 1, which would be here, at spot 2, which would be here at spot 3, and then we want it at spot 4. All right, so... yeah, that's right. I already had the less than. Okay. So... I don't know why my brain is struggling to this algorithm. Because it should be really easy. It should be absolutely really easy. Why am I... I know how I want to do this algorithm. This is so stupid, but I understand it. I'm going to treat it like binary. I don't know if this will make sense to people. To construct every possible one of these, I'm going to treat the spaces like binary. So we have 5 characters here, and there's 4 possible spaces. The spaces meaning 1, 2, 3, 4. These 4 spaces. And the way I decide if I'm going to turn on or off those spaces is by treating them as bits, 0s and 1s. So literally I'm just going to interweave them with a binary value of space or no space, where 0 is no space and 1 is space. Doesn't matter. I'm going to interleave this string with binary. That is so stupid. It's I don't even know if this is the right way to do it, but we're having fun, right? How are we making out now? We're gonna see, Ash. I have some crazy ideas. All right, so num is this -1, and now we need to, for I equals 0, I less than num I++. Is there a way to display a number as binary in bash? I can see the smoke. It must be hard to work. Yo, it's true. It's honestly true. Is there a way to display a number as binary in bash? Let's do this. Or a equals 5. Printf. Percent 0b d. That I'm making this up. 5d. It's not this. Is there a way to make it binary in bash? I don't know the answer to this question. D is probably not it. B? You can do octal and stuff, yeah. I'm actually just going to Google this. I literally don't know. Bash printf print as binary. Yeah, I can use BC to do it, obviously. That's kind of fun. Otherwise, yeah, people are just doing it manually. I could totally do it manually by shifting and stuff. Yeah. Think about this. Yeah, people are using %B. I thought that was right. Right? What am I doing wrong here? Do I have to put like an O in front of it? No. We're just making up syntax now, so this is cool. Oh, they're putting hex numbers there. That's so interesting. Do I have to tell it it's base 10? Is there a way to tell it it's base 10? Nope. Yeah, these solutions are not good. It's so hard to Google, like, good bash things because, like, people always just do the most garbage things. All right, we're gonna implement it ourselves. To binary. Take a number. This will be converted to binary, and the way you do that is really simple. While num shift to the left equals 10 do echo dash n num what mod 10. We just want the remainder of it. Yeah, I might have my shifts wrong. We'll see. Yeah, it should just be repeated division like this. So let's just do 2 binary. Hi. Close. Shifting the wrong way. What am I trying to do? Oh. Yeah, wait, what am I doing? What am I doing? Well, in base 2. We're in base 10. We don't need it that way. What do we want to shift it to? Yeah, that way. Something. We're getting somewhere. I don't know. Let's see. What if people do garbage things best? Is it because they suck at programming? I'm here all week, everyone. You know, get out of here. That's dumb. Yeah, no, I want to shift it this way, right? Yeah. Oh, I'm calling it for each number, aren't I? Yeah. Yep. 2 binary. Let's just do 45, and let's just exit here. See what we got going on here. 45, 11, 2. Yeah, that's looking better. $45, 10. That's clearly not right. What am I doing wrong? Let me think. I just want to shift it 1. Yeah. Oh my god. Yeah, what was I doing? I was completely overcomplicating this. I don't want to shift it by 2, I want to shift it by 1. Yeah. Yeah, shift to the right 1 and then A and 1. Yeah, that works too. I'm doing mod 2, but it's the same effect. Yeah. All the way around, shift for later, and first shift later. I don't know, whatever. I'll think about it. Yeah, it's not 10. Oh, yeah, you're right. Bash doesn't have do while, do they? I don't think it does. I don't think that's a thing. Nah, they have until, but I don't think they have do while. Yeah, we lost the first bit. Yep, exactly. Yeah, Bash doesn't have do while. I don't know what I'm thinking there. I wish it did. It'd be kind of cool. Okay, 0, 0, 1 is 1, 2 is 0, 1, 3 is 1, 1. Okay, cool. Cool. So we're doing really good now. So we can convert the number of spaces into binary. So 2 binary on num. And this will give us the zeros and ones. Then we can change them. So instead of using zeros and ones, we can do like, we could say like, No, we're fine. We'll leave them at zeros and ones, and then we're going to intersperse them. Okay. So, bin equals, do you want to pad them? Yes, we're getting there. So we have bin and we have s, which are strings and the bin directly, whatever. So we can say for I equals 0, I less than num I plus plus, do, done, final equals empty string, final plus equal, what are we doing? We'll get the s at I for one character, and then we will plus equal the bin at I for one character. Then we'll put on the final s, because the s is one larger than the bin. Then we will echo final, and now we should have the original letters with zeros and ones interspersed in them. No, we don't. Oh, yeah, because this should be plus equal. Cool. That is something. I can't help much. I use Go for bashy things. Yeah, dude, I understand. It's all good. It's all right. We're all just here for the ride. 001. That is incorrect. Why are we losing it again? Four is equal to 001. Oh yeah, it is, isn't it? No, we need 4 bits. What am I doing? What am I doing? Okay. I know what I'm doing. I promise I know what I'm doing. It doesn't matter that's backwards. That's not the issue. The issue is padding and counting up to it. This code is so scuffed. Because that is... Well, even that binary representation is actually just wrong. Yeah, it is backwards, but it doesn't matter that it's backwards. That doesn't make a difference that it's backwards. I don't want 4 to binary. I want... I'm not reading chat right now. I'm closing you guys. Okay. I'm not trying to get to the number 4. I'm trying to have 4 possible spaces. That's the issue that I'm looking for. So if I have, 84 spaces, it's like 2 to the 84. I just need every possibility. It's going to be insane how many possibilities there are. Like, insane how many possibilities there are. Alright, let me think about this some more. Nice try, Andre. You're not alone. I'm here. I'm still here. Is Bash awesome? Yeah, I think so. It can be frustrating at times, but I think it's generally pretty awesome. Yeah, because what I actually want is if we have 4 things and we want 4 possible spaces, so we want 2 raised to that number. So we want places equals 2 raised to the number. And that should have 4. That's 5. I guess it might just be 1 higher than it. Yeah, that actually makes sense. Okay, that looks really good. Yep, and it's going to be backwards. I don't care that it's backwards. So now what we can do is we can say this. We can say... I'm super overcomplicating this, and I need to pull myself out of it. I need to... my head's too deep into it to actually make meaningful progress right now. I want there to be 4 places. So that's 2 to the 4 possibilities. 16 different possibilities. What am I doing? What the hell am I doing? Yeah. Okay. We'll treat empty places the same as 0. That solves that problem. Okay, we're getting somewhere. Not getting anywhere meaningful, but we're getting somewhere. Oh. Okay. That's it. That's every possible one. That took 8 years to get there, but we got there. So now this is really easy because we can take... we can do final equals final, find all of the zeros and replace them with nothing. Find all of the ones and replace them with spaces. We should probably print it too. There we go. Okay. That was what I wanted to do. So now if we had -3, the real input, tail -1. This is the string that it's trying to do for the real input. So if we do this, oh god, look at that. Yeah, we're gonna be here for ages. Well, I think this is a dead end. I don't even think this will finish in any sort of meaningful time. Yeah, so that's too slow. So we have to come up with a better way to do this that isn't so slow. How would we do this? Yeah, I don't think this is going to finish in any time that's useful. So how would we actually go about solving this problem? That's a really good question. I do not know. I'll let this keep going in a different window, but I don't expect it to finish at any reasonable hour. I can give you my pun hint, but it was definitely for earlier in the problem. Oh, so like, will the hint not help me right now where I am? Because if that's the case, then go ahead and give it to me. I would love to hear the pun. But yeah, I'm still trying to problem solve how I would even approach part 2. Because yeah, I don't want a hint yet. Yeah, sure. I mean, yeah, give it to me. I'm curious. I'm curious what your pun hint is. You did the best you can do, but did you give it the old college try? T-R-I-E? There are no spelling errors. Well, that hint is meaningless to me. I have no idea how to interpret that. I'm gonna be totally real with you. Yeah, I don't know if that would have helped me. What you can do, but did you give it the old college try? Okay, no, guys, stop. I don't want hints. Stop. I don't want hints. That was specifically for Dark Space. I don't want hints. I don't want hints. Yeah, I wanted Dark Spaces. Yeah. So this is what I'm... Okay. Yeah, I'm thinking about building... So, okay, here's where my brain's going. Every solution we've come up with so far has been exponential. And anytime I'm faced with an exponential problem, I know that the way to solve it is to get logarithmic. And one of the easiest ways to do it is to reach for a tree structure. So my brain's already done that. I'm just trying to think of how I would represent this data. But yeah, no more hints. I don't want hints. But I'm just trying to think of how I would break this into some sort of tree where I could actually make some meaningful progress here. But that's how my brain works. Problem becomes exponential. Cool. I know the opposite of an exponent is logarithm. So I gotta think of a logarithmic solution, and typically my brain will just go to a tree. But I'm trying to figure out how to represent that. Let me think. Bad comp. I was just gonna say, when you make a comment like that, you're like one of the only people where I read it in a completely different tone of voice than I read everyone else's messages. Like when I say that, it's like when you would just tell me, yeah, just make it work. Like just, yeah. Oh, I have too many zeros here. Well, just don't have as many zeros. Yeah, so you just want to let you know, you're like one of the special chairs. I read your messages in like a completely different, absolutely shit posting way. That's the way I read your messages. That's the legacy. Yeah, log tree. I like his train of thought. Yeah, that's how my brain goes. When I think it's exponential, I know I need to combat it by doing logarithms. I know I need to knock out the exponents, or else it's not gonna work as they're intended to be read. Hell yeah. Hell yeah. Oh, hell yeah, Ash. Thank you. All of my thoughts are incoherent. This looks hard. Dude, it sucks. It absolutely sucks. Part 1, 5 minutes. I'm not even joking. I think part 1 took me 5-10 minutes. It was insane how quickly it was. Part 2, I'm whatever I'm gonna do is gonna happen in Minecraft. piano break. Ah, man. I'm thinking, dude. This is brutal. I have ideas, okay? I'm just gonna brainstorm out loud. Where's that head command? Here we go. Couple brainstorms. Take this, chop it in half, start solving for this. Take this, chop it in half, start solving for this. And the way you do that is you chop it in half, you chop it in half, you chop it for half. And then you solve. So I solve like, can B be solved? Yeah, it can. Can BU be solved? Yeah. And then I don't know. If this can be solved, another thing I do is when something is a tree structure, I try to break it into less of a tree structure and just have pointers. So like BU, WU, like BU, could point to BU, and then BU could point to B and U, and then I don't know how to explain it. Does a try help here? I don't know what the problem is. I think it does, based on a bunch of hints people have given me before. And the only thing I know without looking up what that is it's some... Why do I know tries? What are they? Are they tree-like structures? I don't know. It's a... What is a try? It's autocomplete, isn't it? It's like... Is that the thing that's used for natural language processing? Like... Yeah, it's a special type of tree. Yeah, I couldn't tell you anything about it. I bet if I knew it, it'd probably be the thing that helps me out here. But the only reason I've ever even heard of this, I didn't even learn this in school. I'm trying to think of where I learned this. I think it was like literally like 10 years ago, learning about like Siri and autocomplete. Yo, what's up, Chi-Town? How you doing? If at first you don't succeed, try again. Listen, I'm sorry. I appreciate it. But I think Dark Space got the pun award for tonight. I gotta hand it to Dark Space. I just what I like to do for these challenges is I don't like to like Google solutions. I like to just use what I have in my brain. But I realize like what limitation is that? I'm just using things that I've Googled in the past. So I'm trying to think of how I would, without looking up how to implement a try, I'm trying to think of how I would store things in a tree structure, like without. Just maybe it doesn't even give me the answer to look it up, but I'm trying to think of like how would I approach this if I had because I've already done this with different things. I've already done this. You didn't get my pun hint. You gave me a pun hint? No, you didn't give me. Come on, that's not a pun. That's not a pun. I reject that. I can't remember how I solved it. I forgot to memoize how I did it. That's not pun. That's giving it to me on a silver platter. That's not... No, I don't count that. I'm sorry. That's just basically saying, here it is. Here's the word I want you to look at. Look at it sticking out. Sorry, man. I can't give you points for that. Dark Space wins. Maybe you'll like the other and better name for a try. Is it pronounced try? Am I saying this correctly? Pun rejected. I go no. Hey, you're welcome here. I just want you to let you know that we have a high floor for puns in this chat, okay? But no, I appreciate it. Yo, Badcop's one of those people that will just come up with things that I in no way could predict. Like, you're one of those, like, rare people where it's like, no AI could recreate that. Like, I don't know. I never know what you're going to say. It's awesome. Think about it with the hotel with infinite towels point of view. Listen, every hotel has infinite towels if you're annoying enough on the phone. That's the neat part. I don't either. I believe that. I believe you've tapped into pure human entropy. The question it wants us to answer is how many possibilities, how many possible ways can we construct this string using those options? If we can just start caching things. This isn't a tree structure, but if I solve, in order to solve a big pattern, I make the pattern smaller and smaller. And then once I get down to the smallest one, I've solved it and I know how many were possible. Every time I back up through that list, I could keep track of how many were possible. I don't know a good way to do it with how I'm currently approaching things. Dude, those. I know it's my own face that's been Snapchat filtered, but that emote is so funny to me. Like, that is such a funny, stupid emote. I hate it. It's so dumb, dude. I can't look at it. It's literally so dumb, dude. I can't look at it. It's so. Come on, it's so stupid. Oh, man. All right. Because it's funny. I added it because it's funny. We're doing this all recursively. So we lose track of what's possible. I don't know how to keep track of this. What am I trying to do? All right, if we have BRWRR and we solve it with this, the way we would have gotten there would be like that. So we know that B means 1 is possible. And we know that this is 1 is possible. This is 1. And when we go up this tree structure, this, if we ever see this string again, that means it was 2. How do we keep track of that string as we recurse in? I don't know if we need to keep track of the whole chain or if we just need to keep track of a parent. I'm describing like an unrolled tree structure. I'm aware of that. And we know if the solve pattern was successful, we increment how many are possible, then we know we need the pattern we're checking and something else. What am I trying to cache? Let me think about this. Then we chop off the available from the pattern and we have a new thing to check, which is smaller. Let's see. I don't understand what I'm trying to cache here, but I'm getting somewhere. I have an idea. Once we get here and we know there's no more pattern left, we can store our cached information. Because we know that the pattern before it that got us here had 1 solution. The pattern before that had 2 solutions. It's the layer deep we are. Let's try this. Let's make something up. No, I don't like this. totally making up something crazy here. Okay. When we solved it, we found a solution that worked. The leg that we got down to was this. These were all the items we got. This is rebuilding the string. So we know that this one... We should know that this was one that worked. We don't know if it was all of them. So we know that UBG is one, but UBG would just be one of the patterns. How long do we cache until? I guess until a whole word is done. Yeah, because that was only one solution. We got all the way deep into one solution. I hate it. I hate that emote. I love it. It's so ridiculous. It's just a Snapchat filter called handsome. So when we get down here, we know that the pattern we're trying to solve is empty, so we're like, oh, we got it. And we know that this is the constituent part that got us there. Yeah, so W can only ever be one. BR can... Well, this is confusing too, because BR could be a solution. Yeah, it is going to be a solution for that one. I do not understand how to do this. The problem is the way that we're doing this is we're jumping into each solution. We're going depth first into each solution. I wonder if we want to not do that. I wonder if we want to breadth first into all of them and then count how many layers up it was. I don't know what we want to do, guys. I'm gonna be honest. I love bread first. Dude, I love bread so much. Oh my god. No, because it's never going to solve if we do it that way. I don't understand how to do this. Oh, grilled cheese on a sourdough? Delicious. Oh, I could go for a grilled cheese right now. Oh, man. Dude, oh, man. Like 12 years ago? 13 years ago? 14 years ago? I don't remember when it was. When I lived in San Francisco. Oh, my God. Or outside of San Francisco. On 2nd Street, there was the American Grilled Cheese Kitchen was the name of the place. Dude, I used to get grilled cheese from there all the time. Oh, my God. It was so good. Now I think it's a coffee shop. I think it turned into, like, Blue something coffee. And it's like, whatever. Good hot chocolate, but yeah. Oh, I missed something in the YouTube chat. I'm sorry. Just spitballing, but what happens if you sort the constituent substrings to ID proximal candidates? I'm going to be honest. All the words you use there are above my pay grade. So this string was constructed from this string, was constructed from this string, and this worked. This was right. There's no guarantee this is as low as we go. We just know that if we hit UBG, we're done. And that means UUBG has one child. What are these? What does this get us? I don't understand. This is just one solution. This is one leg of the tree. We fell all the way down the tree and we got this answer. Is this helpful? I almost feel like at first we need to go through all the possible patterns and figure out what patterns can be used to make other patterns. Like, WR can branch out into nothing. RB can branch out into RB, but RB is also terminal. So, chat message. Your chat message, like when I'm installing Linux and I mess up grub. When I install grub to a partition and not the raw disk. When we encounter a new word that isn't cached, we need to keep track of how many things came out of it. So when we encounter a new pattern that is not cached, we're done here. If we encounter one that's not cached, or that is cached, we just return the cache right away. Now we have to figure out when do we actually create the cache. The way we create the cache is here. I don't know, we're just going to use this as a symbol. We're just going to return 5. I have no idea why. No, we have to somehow transmit this number back up. And we can't do it with return codes. This number could be gigantic. Yeah, how do we cache this? I'm saying generate all permutations first, then use that to check against the list of options. Yeah, I think we tried something like that. I don't remember. Hold on, I can't think about that. If it starts with it, then we know that that is in there. And we know that it has a parent, so we're keeping track of the parent. We gotta warm the cache up. Warm it up and then solve each pattern, because each pattern might be a subset of another set of patterns. It's not cached, so we move on. Break it into the constituent parts, we check the new pattern. And if that one leads us to this, then well, everyone is marked as unsolvable. Oh yeah, wait, no, this isn't gonna work. I do this first. Okay. I think I have an idea. Let me make a simple input. We have R, W, and RW. And our input string will be RW, RW. I don't know. Who cares? It's not par. Bar dump. We never actually cache the data. Okay. But we do call solve pattern on each thing. Okay. Should be done 3 times. How do we get out of here? yeah, we're using foo. Yeah, what's up, Captain January? Yeah, we're still live. We're still trying. Kind of regretting getting this far into it, but it's okay. No, it doesn't matter. It doesn't matter. I know it's slow, but it doesn't matter. Oh, I shifted it. Okay. So when we're done, we had an R that finished, we had a W that finished, we had an RW and an RW. Okay, so when we get here, we know that R is 1, W is 1, RW is RW. We can just warm this up to their values. But I don't understand when we use the cache. I think we just need to return the total, right? Yeah, so we do this. If we're at the end, and we set the cache of the parent increments. This will only happen when we're breaking down things. If we have a cached value here, then we just echo cached and return. I think we're onto something. Oh, I can't echo too much stuff in here. Yeah. Okay. And then, so we solve the pattern. And now that we've solved the pattern, look in cache to see how many were made. For pattern in pattern, echo n equals cache pattern, echo n and pattern. Okay, getting there. Okay, we have a cache of everything here. Now they're all set to zeros, but we have a cache of everything. So that's kind of huge. Oh yeah, we increment the cache, and then if we're empty, we just echo 1. Okay. Okay. Now if we do this, total equals 0, total plus equal n, echo found total. Found 16. What were we supposed to find? 16. Okay. Okay. It's ugly. It's real ugly. What does this look like for the real input? Let's speed it up. Let's get rid of some of those echoes. I don't know what these numbers are or where they're being echoed from. Okay. This was caching the available patterns, right? Now, if this is working, what it should be doing, it should be traversing into a solution, and then when it comes back up, it should know how many solutions there were down there. And this should be getting faster. Although I don't know how long it takes to read from a cache in Bash. I can go back to using foo. Okay. Well, that didn't work. Well, we managed to get a cache. Something happened. That's right. There's 20 different ways, 21 different ways that can be constructed. I guess that's probably right. Did you end up using the binary separator you were implementing? No. I'm trying just to cache all the prefixes I see. For some reason this logic's not matching. If pattern, the big string, equals star avail star. That sounds right. There we go. I could also write these cached values out to the file system when I commit them. Hold on. Hold on. This seems a lot faster. I have no idea if this is right. This is definitely, it's cranking through the out or the input. Okay. 28050. Okay. Let's store that. And yo, what's up? What's going on? Bash Daddy streams on Twitch. You know I do. Before I run that, I'm going to run it against the example, which should give us 16. Gave us 32. Okay. Why are we getting twice as high? Could be something with the cache logic. Yeah, I think it's that. I think we're double caching things. I was wrong. If there's no pattern, then it's just one. We made it there. Yeah, answer divided by 2. Literally, it might be. But I kind of want to figure out why we got there. What we could do is we could just exit after the first word. Or, break after the first word. Because the first word's supposed to give us 2. And we got 4. So why do we get 4? Or why do we get 4? 4 because... Yeah, BRWRR. 2 different ways. BR... WRR or BRWR R. Bash Daddy. I hate it. No, it's fine. I don't mind it. Yeah, let's see. No, this is wrong. No, I'm double implementing everything again. That's why I'm doing that thing that I always do. Where I, like, double implemented every pattern when I don't need to solve a pattern because I know that the pattern is the solution. Yeah, I'm doing this poorly. I just need to warm the cache, like, instead of solving it, I literally just need to do cache pattern equals 1. That's what I need to do. Still wrong, but yeah. Do we echo 0? Yeah, how are we getting 4? This should never be happening. If the pattern is empty, we should have caught it with the cache first. You were doing great and then you played the piano. Listen, the piano might actually be cursed. It's true. BRWRR. Yeah, we're calling it with that. I don't understand how it's a bad array subscript when it's like this. Oh right, yeah, I can't do this. What am I doing? Yeah, they're all getting called with nothing. Should be 2. Yeah, that's not right. Oh, look at that. I'm stupid. 2. Okay, I was just using the wrong variable. Dude, these little bugs, man. They add up. Found 12, and we were supposed to find 16. Neat. We found 2, 1, 2, 0. 1, 2, 0. How are there 7 here? How are there 8 there? Oh, there's really 8 here? Oh, some of them are unsuccessful. 2 of them should be failures. Yeah, okay, so there were 2 failures. 2, 1, 2, 4, 2, 1, 4, 6. This should be 4, and this should be 6. Okay. Yo, dude, Advent of Code's fun, man. Like, it's a little bit frustrating right now, but, like, I'm still having fun. Alright, so which one was giving me problems? No, it's okay. Dark space. I'm okay. I'm still bumping up against the example. Like, I still can't even get the example to work in a way that makes sense. GBBR can be solved 4 different ways, and we only came up with 2 solutions for it. That's what I was worried about. Removing G from GBBR, solving pattern BBR, removing B from BBBR, solving pattern BR. Yeah, because BR can also be broken into B and R. Yeah. And BR is just 1. Yeah, but then we should also... We should also be, when we solve BR... Oh, we already have an answer for BR, but it can be solved even lower. Yeah, maybe we do need that, No, it should be doing this. For loop, I think, is the wrong approach. Yeah, maybe. I don't know. I'm too far into it now. Yeah, it should be looping all the patterns. Maybe this logic is just flawed. Let's try this. Nope. Okay, remove G from BBR. Moves B from BBR. Why doesn't it remove BR from BBR? Solve pattern BR. Alright, let's make it even simpler. Yeah, see, it only finds one for BR, and that makes sense because we have a cached one, but it can also be broken into B and R. So why are we not looping over that? Yep. We already have a cached answer, so I'm pretty sure we just exit as soon as possible. So I think when we do warm the cache, we need to actually traverse into each one and do it like we did before. We had that logic to warm the cache here. But why? This is just for the initial one. Yeah, like two is what, right? Yeah, BR and then B and R. I guess that is two solutions, yeah. Found 16. Okay, that's what it's supposed to find. I had that logic before, but I must have had something else that was not working. Because I definitely had that logic before. Vim, real input. Yeah, I don't know what you're saying in YouTube chat. You're right. Like the RB can be three solutions. That's what I'm bumping up against here. I had logic in there before to handle it, but it wasn't working, so I just put it back in there. Recursion would solve it by trying each thing, then removing successful chunks, then recursing again with the new string minus the found part. If the string ends up as 0, then it's okay. That's exactly what I did. That is exactly what I have. My solution is a recursive solution that calls itself, and I strip off the part that I don't care about anymore, removing a val from pattern. So I check if the pattern I'm looking at starts with the towel I have available. Then I strip that part off, and then I call myself recursively, and then I add whatever number of solutions I had from that recursive call. And that's how I bubble up the recursive answer. Am I still caching? That was a big one that went by. I think what you did is called backtracking. I think what I did was called over-engineering. No, I love how you are figuring those concepts out in the go. I totally am, yeah. Yeah, I don't mind. I mean, this is how I like to program, so it's cool. I have to sit here and problem solve them. So technically speaking, this thing should get faster as it starts caching more data. I am curious just how long this first one will take, though, because I feel like that's significant here, right? how long are the strings here? I'll show you. This is what the real input I'm working on is. So at the top, these are all my possibilities, and there's more than what you see. I think there's 440 possibilities, and the strings I'm solving for are like this long. I think that's just too many. Let's get some debugging in here. Yeah, we'll never know how deep this thing gets. So, is it okay to point out problems with the code itself, as in ways, places where I think the code is not doing what I think you intend to do? So, sure, yeah. If like you see bugs or something where I'm like clearly not doing it, yeah, I think that's totally fine. I'm also not even totally thrilled with my approach here. So, yeah, feel free to do that. I don't think I'm caching the right thing. I'm caching these like extra ridiculously long substrings that just don't do much for me. Will the cache be populated correctly when the recursion happens in a subshell like that? No. No, it won't. No, it won't. Wait. It might. Let me think about that. Let me think about that. Where do I set cache? I set solve pattern sets cache, and solve pattern gets called in a subshell here. So it can never. Yeah, when it gets called in a subshell. It won't do that. You're right. You're right. That won't work. Yeah, I'm not filling the cache. Good call. Very good call. Now what do I do about that? Let me think. You're absolutely 1000% right. Write the cache file. I was literally about to say, I think I need to cache it to a file. I think I need to use the file system as my cache. Literally was going to say that. To bubble up, I'm bubbling up the total number. There are other ways of returning values to the caller. True, I could set a variable or something, but like, I need to keep track of where I am. I'd have to give it like a unique ID and set it somewhere that I can retrieve it later. Because even if I did like a return code in Bash, it's limited to 0 to 255. I could give it a unique index in an array and set it there. Yeah, but I think file system might be the way to go for now. I'll think about how to do it in memory, but for now, I just like this solution. Let's see, NMBB. Did you have a YSAT video about this, about variable notations? I absolutely did. 100% I did. Yeah, it just goes to show anyone can make mistakes, man. It's because I added that subshell and stuff later. Didn't even think about the effect it would have. I'm curious what this looks like now. Are you checking each cache entry once? I don't know what I'm doing anymore. Hey, that's kind of neat. Why does it say no such file directory? Like, didn't I throw out devnull? Whatever, we'll just use cat. Found 16. Okay. So this should be filling this cache up. Nice. Cool. That's pretty fun to watch. Hey, look at this. This looks way better. Yo, shout out Edorfaus. I don't know how to pronounce your name, but yo, shout out to them in the Twitch chat, dude. I don't even know how long it would have caught me to realize that cache wasn't growing. Now, who knows if I'm gonna get the right answer, but like, I don't know if I would have caught that or when that would have happened. That's amazing. Caching the file system's cool too, because, you know, it's static, it's persistent. Like, if I Control-C this and run it again, we should be good. I'm not going to, but we should be. How many things do we have in the real input? 402, 2 of them are just whatever lines. Okay, so 400 we had to run. I didn't put any, we don't have any sort of progress indicators. But that's okay. I wonder how close we are. Huh. Cache is getting pretty big. Wonder how many, 34 megs of data. That's amazing. The video about subshells. Yeah. Oh, yeah. It's tough, man. When you're programming iteratively and you're just like, oh, yeah, I'll just wrap this in a command substitution because I want to capture the output. You don't even, like, it's so easy to not even think, like, oh, yeah, that will hide, you know, the output. That will hide being able to mutate shell variables, things like that. Yo, let's go. Are you all ready? Let's go. Let's go. Let's go. Persistence pays off. Oh my god. Listen, that was ridiculous. I can't even believe that happened. Yo, oh man. Listen, yo, Dark Space, you're awesome. I love that you stay here till the end. That's so awesome. I know you just like have me on while you're like working on other puzzles. I think that's sick. And yeah, I mean, like, here's the thing. You guys were totally right. Like, the tree solution is the way to do it. My memorization, I abused the fact that my recursion was going down into a tree, and then in order to get my global state in Bash, I just used my file system. So it is what it is. Here we are. Thank you so much. Yo. Shout out Edorfaus. I don't know if I would have gotten... I don't know how long it would have taken me to realize the cache wasn't populated. Maybe I would have done it next, but, you know, who knows? I have no idea. But, yo, appreciate it, man.